this is GATE 2013 question number 48, which is a common data question. So there are 4 energy levels, E, 2E, 3E and 4E, which are given, and E is greater than 0, which is already a condition which is given. We need to find out the canonical partition function of the 2 particles if these particles are, for question number 48, it comes out to be 2 identical fermions. So there are 2 identical fermions and there are several energy levels. There are 4 energy levels. Degeneracy is not mentioned, so we will not consider it right now. We need to find out that for 2 identical fermions, what will be the partition function. So to understand this particular question, what is given condition are that 4 energy levels are there, E, 2E, 3E and 4E. We need to find the canonical partition function of the 2 particles. Here the 2 particles are the 2 identical fermions. Fermions, we need to know that these fermions has a property that no two fermions can accommodate one energy level. So that means what? One fermion can accommodate any particular energy level. So this is how the distributions looks like. First combination will be one particle is at E, second is at 2E. Second combination, one is at E, second will be at 3E. Third combination, one is at E, second will be at 4E. Fourth combination, one is at 2E, second one is at 3E. Fifth at 2E and 4E, and the sixth at 3E and 4E. So now the energy of those particle system, the 2 identical fermions system, will have the lower level energy as 3E, that is E plus 2E. These two combined, 2E plus 3E, 2E plus E becomes 3E. Second level will be 4E. Third level will be 5E. Fourth is also 5E. That means this has the same kind of energy. Fifth is 6E and then 7E. So these are the different levels of energy when you have 2 identical fermions accommodation. Partition function is given as Gi e to the power minus beta epsilon I, where beta is actually 1 upon kBt. Gi is the degeneracy at the ith level and epsilon I is the ith energy level. Now because of the 2 identical fermions, we have the lowest energy level at 3E, it goes on, and at highest energy level at 7E. Therefore, we will just put it for fermions. Partition function will be Z is equal to e to the power minus beta times 3E, because that is the lowest energy level. Next 4E, so this will be 4E. Next e to the power minus beta into 5E. Again e to the power minus beta into 5E. That if you combine, you will understand that this for 5E energy level, there are 2-fold degeneracy. Then e to the power minus beta 6E and e to the power minus beta 7E. All these levels are non-degenerate. There is nothing mentioned in the question about the degeneracy, so we have assumed that it is non-degenerate. And once we do it, we can see that 5E is repeating twice, so that means it's a kind of a degeneracy at the 5E energy level when 2 fermions are there. So all are non-degenerate, which we have assumed. So Z becomes e to the power minus beta 3E plus e to the power minus beta 4E plus 2 times, because there are 2 times 5E energy level is there. So 2 times e to the power minus beta 5E. You can call this 2 as the degeneracy for the 5E level when you have 2 fermions there, and e to the power minus 6 beta E plus e to the power minus 7 beta E. So answer will be the B option is the correct option. So if I come back to the question, it is that for the 2 identical fermions, the particles, the canonical partition function for these 2 particles becomes this one, B, that is e to the power minus 3 beta E plus e to the power minus 4 beta E plus 2 e to the power minus 5 beta E plus e to the power minus 6 beta E plus e to the power minus 7 beta E. So B is the correct option. Thank you.